Okay, so we're just gonna do a quick review from yesterday's greatest common factor lesson. So when we're talking about greatest common factors, it is the biggest number that can go into each of these evenly, okay? So when we take a look at the very first question, we can even write them over here. So we can go, what goes into 4? So 4 times 1 and 2 times 2. Okay, let's find the factors that go into 8. So 4 times 2 and 8 times 1. And the factors that go into 20, we have 4 times 5, 2 times 10, and 20 times 1. So in all 3 of these, we can see that there is a 4. So what we're going to do is bring the 4 out front. Okay, so when we're going to be writing this, we're going to bring the 4 out front. And then we're going to put everything we need, or everything that's left over, in these brackets. So the things that are left over is we take each of these numbers and we divide it by 4. Of course, you're not going to work for me. And we divide it by 4. So if we do 4 divided by 4, we get 1. So we can do 1x squared plus 8 divided by 4 equals 2. So we can do 2x, and then minus 20 divided by 4 is equal to 5. Okay, so these are the things that are left over. And what you notice too is that it is everything that is multiplied with the 4 is going to be remaining. Okay? So when we take a look at the next question, we're going to figure out what is the greatest common factor that goes into all of these numbers. So we're going to write 10 and 20. I'm just going to, and 5. So what goes into 10? We can do 10 times 1, 2 times 5. And then we'll take a look at 20 and we can do 20 times 1. We can do 2 times 10. And we can do 20 times, oh, I already did that, 4 times 5. And then we take a look at the 5 and we go 1 times 5. And that's it. So what goes into each of these? Well, I see a 5 here, a 5 here, and a 5 here. So I'm going to write 5. And then bracket. So what I'm going to do is I'm going to do 10 divided by 5, which is 2. And then I write the rest of x squared plus 20 divided by 5 is 4. And then x minus 5 divided by 5 is 1. Right, and to make sure that we've done this correctly, what we can do is we can take this 5 and multiply it back in to each of those to see what we would get. So 5 times 2x squared is going to give me 10x squared plus 5 times 4x is going to give me 20x. 5 times negative 1 is going to give me negative 5. So I did it correctly. Now we need to note that sometimes we can take out a number and a letter. Okay, so we see how there's an x on this one and an x on this one. So we can bring an x out front as well. So if we're taking a look, and we can bring first let's start with the multiples of 4, the factors of 4, sorry. So 4 times 1 and 2 times 2. And then we'll take a look at 8. So we can do 8 times 1 and 2 times 4. Okay, we see that it's 4 and 4, so we can bring a 4 out front. And we also see, since there's 2 x's, right, that we can bring it out front as well, because x is in both of the numbers. And then we put everything else that's remaining inside the bracket. So 4 divided by 4 is 1, and we have 1x left, right, because we would divide it by 4x. And then plus 8x divided by 4x, we get 8 divided by 2 is 2, and x divided by x is 0. And then we will take a look at the next one. I'm just going to draw a straight line here. So we're going to look at 7, 14, and 28. All right, let's find the multiples of these. So the multiples of 7 are 7 and 1. 14, we have 14 times 1, and we have 7 times 2. And then 28, we have 7 times 4, we have 14 times 2, and we have, I literally just blanked, 28 times 3, but we don't need to go any further because we can see that 7 is the biggest one in all of them, okay? Sorry, 28 times 1. I don't know why I said 3. So we would bring 7 out front, and we can also bring the variable out front too, because we can see that there is an x in all of them. So if we bring one of the x's out front, we're going to put the remaining ones left. So we have 7 divided by 7, which is going to give us 1. And because we pulled one x out front, we have 2 left over. Minus 14 divided by 7 is 2. And then we pulled one x out front, so we have 1 left over. Plus 28 divided by 7 is 4. And we pulled one x out front, so we have none left over. Okay? And then we can go on to do the next one. We can do, so we'll do 4, 6, and 12. Let's find the multiples of these. So we can do 4 and 1, 2 and 2. We can do 2 times 3, 6 times 1, 12 times 1, 2 times 6, and 3 times 4. But we can see that the 2 is the greatest common factor in all of them. So if we bring a 2 out front, and then we take a look at the x's, okay, we have an x in each of them, but one thing you need to note is that there's 2 x's in this one. So we can pull 2 x's away from this, we can pull 2 x's away from this, and we can pull 2 x's away from this. So we bring in x squared out front. Okay, because there's 2 x's, a minimum of 2 x's in each of them. And then so what do we have left over? Well, 4 divided by 2 gives me 2. And if I've pulled 2 x's out front, we have 3 left over. And then 6 divided by 2 is 3. And we have pulled 2 x's out front, so we have none left over. And then 12 divided by 2 gives us 6. Oh my goodness, I can't math today. Gives us 6, and we've pulled 2 x's, and we initially had 3, so we have 1 left over. And then we just bracket it. Okay? So then if we're going to take a look at x squared, sometimes you will see them that just look like this. Okay, so when we look at it, The only thing that's the same between each of these that we can pull out, so the greatest common factor is going to be a 1x. So we bring x out front, and then we bracket, and we have 1x left over. And we have a 6 left over. And then we bracket it. Okay? So then when we go take a look at things that we have learned so far. So we have learned how to factor in standard format, right? We've learned how to factor using this. So if we were to factor this, we know that we can use our area model or our window, and we go put in the information that we know. So we have our x squared here, our negative 12 here, and our negative 4x here. Okay, so when we have the negative 4x here, this equals. So we now have to find the things that add to 4 and multiply to negative 12. So if we go on and figure out what things multiply to negative 12, well, we can do, I'll just put this up here, negative 12 question mark. So we can do a negative 3 and a 4 and a 4, negative 4 and a 3. And we can do negative 12 times 1, negative 1 times 12. We can do 2 and a negative 6. And we can do a negative 2 and a 6. Okay, so these are everything that multiply together to get 12. So do any of these add to negative 4? Well, this one equals negative 1, or positive 1, out. This one equals negative 1, out. This one equals negative 11, nope. This one's going to give us positive 11, nope. 2 plus negative 6 is going to give us negative 4. So these are our winning numbers. So when we put these back into here, we do plus 2x, don't forget the x's, and negative 6x. And then we can pull our information out of the window. So we have x, and we have plus 2, and we have minus 6. So our factors are x minus 6 and x plus 2. Okay? We also learned the difference of squares. So remember, when we're talking about the difference in squares, we have to make sure that it is a number times itself, right? It has to be a perfect square. That being said, so we need to take a look, and we need to make sure that it hits all of the points. So there is a negative. Yep, there's no x term, correct? And we have a perfect square, right? So this means that it is 5 times itself. So what we get to do with that is we get to do the shortcut where we do x plus 5 and x minus 5. Okay? And we can do the same thing here. So the reason we can do this is because we have a negative here. Check. There's no x term. Check. And these are perfect squares. Check. Because 2 times itself gives us 4. And 3 times itself gives us 9. So when we bracket this out and we factor them, we can factor it as 3x, because we take one of these x's, plus 2. And then we made one a positive, so we have to make the other one a negative. So we have 3x minus 2. Beautiful. And the next thing we have is the greatest common factor. Okay, so we just did this on our other page. So what can we do? What is the greatest common factor that goes into all of them? So we have a 5 and we have 20. So to get 5, we can do 5 times 1. And we can do 20 times 1, and 10 times 2, and 5 times 4. So we can see that 5 goes into both of those, so we can bring the 5 out front. And then bracket, so then 5 divided by 5 is 1. But the thing we need to note is that they both have x's. So we can also bring an x out front. Okay, because they have the same, they have an x in this one and there's an x in this one. So we have, when we bring the x out front, we have one x left. And then minus, so 20 divided by 5 is 4. And because we brought the x out front, there's no more left. Okay? So then we're gonna go to the next page. And what we're going to do first, I know you don't have a partner. The very, 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 very first thing that we need to do is we need to always look to see if there's a greatest common factor, okay? So we're putting a lot of the things that we've just learned together. So greatest common factor comes first. So can we take a look at the very first one? Can we factor this out anymore? No, we can't, because 1 can't be factored anymore. And there's, if we take a look at the variables, there's an x here and an x here, but there's not 1 in here. Perfect. Okay, so we know that we can't bring anything else out. So then when we factor, we can use our window method. Okay, when we use our window method, we get, so we have x squared and we have 35, and they equal to negative 12. And then when we do the math and we figure out what multiplies to 35 and what adds to negative 12, we get negative 5 and negative 7. Sometimes my 7 just don't look like 7s. And then we can bring this information out. So we have x here, x here. These are x's. Don't forget your x's. I just forgot mine. Minus 5 and minus 7. So we get, I'm going to do this in a color. We get x minus 5 and x minus 7. So we'll go to the next one. So number 2. What can we pull out of here, right? We're gonna look to see if there's a greatest common factor. Greatest common factor in these, we can, I'm gonna tell you now, we can pull out a 4, right? So we can pull out a 4 in the front. Can we also pull out an x? Is an x in all 3 of them? Yep, we can. And then we can put the rest of the remaining stuff in here. So 4 divided by 4 is 1. We pulled out 1x, and there was initially 3, so we have 2 x's left over. And 8 divided by 4 is 2. We pulled out 1x from this, and we have 2 initially, so we have 1x left over. And 12 divided by 4 is 3. And we pulled out this x, so we have no x's left over. Okay? And then remember, when we have an example here as a, this is a perfect square because we don't have an x value. This is a negative, right? We don't have, like, there is no x value here. This is a negative, and 7 times 7, so 7 times itself, gives us 49. So we can go write this in the shortcut way. We can do x plus 7 and x minus 7. Lovely. We'll take a look at the next one. So can something be pulled out front here? Yes, something can be pulled out here. I don't know why I'm grabbing a pencil. Yes, we can pull out 3 because 3 can also go into 12. So when we do that, we can pull out a 3, and 3 divided by 3 is 1. Can we also pull out a variable? So can we pull out an x? Yes, we can, because there's an x in both of these. So we can pull out an x. Now what's left over? So 3 divided by 3 is 1. And we pulled out 1x out front, and we have 1x left over. And 12 divided by 3 is 4. And we pulled out the 1x, so we have no x's left over. Okay? So now what we've done is we have learned about the 3 types of factoring, right? We just reviewed that there are 3 different types. So we have the window method for the trinomials. We have the difference of squares, which is when we have perfect squares. And we just did greatest common factoring. So when we take a look at this question, we already did this one. So we pulled out the 4 out front. We did it on this page, right? We pulled the 4 out front and then x out front. And then we put the remaining left over inside of it, 2x minus 3. Okay, so what can you notice now about the bracket? What does this look like? This is in the same format as our standard format, right? See how it's the exact same looking as this. So it's x squared, x, and a regular number. So what we can do here is we get to do the window method for this. Okay, so we have 4x out front, and we get to do the window method for the bracket. So let's take a look and do our window method for the remaining leftover. So we have an x squared here. We have a negative 3 here. And we know that these two added together equal 2. So now what we need to do is we need to find what multiplies to negative 3 and adds to 2. Okay, so what multiplies to negative 3? Sorry. I feel like every day you guys hear my ambulance is going on. So what multiplies to negative 3? We have a 1 and a negative 3. We have a negative 3 and a 1. And that's pretty much it. So, do these two added together give me 2? Oh, it gives me negative 2. Do these two add together? I guess there should be a negative. Do these two added together give me 2? Yep. So these are our numbers. So we can plug these back in, and remember, put the x and negative 1x, and then we can pull our information out. So this goes x and x. This is 3, and it's positive, and this is a minus 1. So we can write these as x plus 3 and x minus 1. And then we can plug this back into where it just was, because this standard form and this are saying the same thing. So we can do 4x, and then we bring this over, x plus 3 and x minus 1. So we're just taking an extra step. So initially we learned this one. Now we're adding the greatest common factor and our trinomials together. So we're taking out a number, we're taking out a factor, and then we're able to use the window method to find our factors. So how do we know if we need to do multiple steps? Well, let's take a look. So we need to see if we have a common factor, right? Can this be taken, can numbers be broken into smaller points, smaller numbers. Yep, so we can see that this one did. So yes, so we factor it. And then is there an x squared term left over? Right, there was an x squared term left over here. So we can factor again using the window method. Is there a greatest common factor? If there's not, so if we can see, for example, this one, there was no greatest common factor, right? Nothing else can be pulled out. So we go down here. No, there's no other factors to do. Okay, so is there an x squared term? Yes, we can see here that there is an x squared term. So we must use the window method to factor. If there was no x squared, then we're done. Okay? So let's go practice some. So we want to take a look first. Very, very first thing we do is there a greatest common factor? I always assume that there's a greatest common factor if there's a number in front of our x squared. Okay, so let's find out. So let's find the multiples of 2. What can I multiply together to give me 2? I can do 2 times 1. What can I multiply together to give me 10? 10 times 1 and 2 times 5. What can I multiply together to give me 12? 12 times 1, 2 times 6, 3 times 4. And the same thing in each of these is a 2. So we can pull a 2 out front. Now we need to look to see if we can pull an x out front. There's an x in this one, there's an x in this one, but there's no x in this one. So we can't pull an x out. So then we bracket. So 2 divided by 2 is 1. So we just write x squared. You can put a 1 in front if you'd like. Plus 10 divided by 2 is 5. And we have our x. And 12 divided by 2 is 6. Okay, so now we need to take a look. Is there an x squared term? Yep, there is an x squared term. So we need to factor again using our window method. So we take this part here and we put it in the window. Okay, so we have, I don't know why I drew that so slowly. So we can put our x squared in here, our plus 6 in here, and we know that they must equal to 5x. So what are some things that multiply to get 6? We can do 2 times 3. We can do 6 times 1. We can do some negatives, but because this is a positive, we're not going to need to. So 2 plus 3, does this equal 5? It sure does. So these are now our x values. So we put 2x in here, don't forget the x, and 3x in here. And then we can pull our information out. And we have a 2, an x, and a 3. And then we can write these as x plus 2 and x plus 3. And then we come back over here. Sorry. We come back over here and we have a 2, and then we sub this into here, and we can do x plus 2 and x plus 3, right? Because this is just the factored form of this. So let's try another one. So, as I'm dropping papers. So, if we take a look at this, we need to double check. Is there something that can be factored out? Yes, there is. We can take out a -4. because 16 goes into 4. Because if we look, we can go, what are the factors of 4? And what are the factors of 16? Well, the factors of 4 are 1 times 4 and 2 times 2. And 16, we can do 1 times 16. We can do 2 times 8. And we can do 4 times 4. So the greatest common factor is 4. So we can bring out a 4. But one thing we can do too is we can pull out the negative because they're both negative. So we can pull out the negative here, and we can pull out an x as well. Okay, so we can pull out an x out front here. So then negative 4 divided by negative 4 gives me 1. And we pulled out 1x, so we can put an x there. And then we have a negative 16. So negative 16 divided by negative 4 is going to give me positive 4. And we already have an x pulled out, so we're done. Is there another x squared term? Nope. So we're finished. We'll practice one more. I'm gonna grab a different color. So if we're gonna take a look at this one, do we have a greatest common factor? Always look, do we have a greatest common factor? Well, let's go find out. So if we have, what are the multiples of 5, 30, and 40? Okay, what are the multiples of 5? The multiples of 5 are 5 times 1. What are the multiples of 30? We can do 30 times 1, 15 times 2. We can do 10 times 3. We can do 5 times 6. What are the multiples of 40? We have 40 times 1. We have 20 times 2. We have 4 times 10. And we have 5 times 8. So we can see that a 5 can be pulled out. And what I would do is, because we have a negative 5, I would pull the negative 5 out front. Okay? Try and make the inside as pretty as possible. Okay, so we want all of, if this one's going to be a negative, we want to pull the negative out front too. Can we pull out an x value? No, we can't, because there's an x here, but there's no x here. So what is negative 5 divided by negative 5? We get 1, x squared. And then we have 30 divided by negative 5. We get negative 6x. And then negative 40 divided by negative 5, we get, so plus 8. You guys can use your calculator for this, okay? And then we would take this and put it into our window, right? Because we now have the standard form, a very pretty standard form. So we take this and we put it in our window. So we have x squared here, we have 8 here, and we have these two equal to 6x. Okay, so what adds together to give me 6x and multiplies together to give me 8? We can do 2 times 4, because to get 8 we can do 2 times 4, and we don't even need to look any further because we see that this equals 6. So our numbers are 2x and 4x, and then we can pull our information out. So we have 2x, x, and 4. These are positives. So then we can write this as x plus 2 and x plus 4. But we need to remember that we still have this negative 5 out front. So we go, I'm just going to use some space up here. So we make sure that we write negative 5 and then our factored points. Okay? So I know this is a whole step process and it takes a long time, but I want you guys to practice some of these, okay? So I have these for you guys to practice. I'm gonna take a picture, I'm gonna get you guys to practice them, and then I want you to double check your answers that I'm gonna post that you got them right, okay?